Welcome, ladies and gentlemen. Today we're going to be talking about laws of exponents. Now, this shouldn't be too bad. We're going to have mostly a review from Algebra 1 concepts. All right, first thing we're going to talk about is what an exponent is in general. Now, an exponent is made up of a power. This whole thing is a power. The 5 represents the base, and the 3 represents the exponent. Now, an example of this is 125 equals 5 cubed, which means that 5 cubed is the exponential form of the number 125. Now we're going to be using both of these forms quite a bit later on, so it's important to see that they're the same thing. Now 5 cubed means 3 factors of 5, or 5 times 5 times 5. Now we're going to be talking about the laws of exponents. There's going to be 8 laws of exponents. So here is our first law of exponents. Number 1, exponential form. The exponent of a power indicates how many times the base is multiplied by itself. So we're going to have x to the n. We're going to have x times x to the nth number of times. So however many numbers it's going to be. An example of this in factors of x. An example of this is going to be 5 cubed equals 5 times 5 times 5. Now our second law is multiplying powers. If you are multiplying powers with the same base, keep the base and add the exponents. So in terms of variables, I have x to the m times x to the n, which equals x to the m plus n. Now, an example of that is going to be 2 to the 6 times 2 to the 3rd, which is going to equal 2 to the 6 plus 3, or 2 to the 9th. If I type that in my calculator, I'm going to get 512. So I get it! When you multiply powers, you add the exponents. But it's important to remember they have to have the same base, okay? Same base. Law number 3, dividing powers. When dividing powers with the same base, keep the base and subtract the exponents. So this is very similar to multiplying. In terms of variables, I have x to the m divided by x to the n. So this is one way to write it. This is another way to write it. X to the m divided by x to the n. It's going to equal x to the m minus n. So it's always the top number exponent or the first exponent subtracted the bottom or the second exponent. Now an example of this is going to be 2 to the 6 divided by 2 to the 2nd, which equals 2 to the 6 minus 2, which equals 2 to the 4th, and 2 to the 4th equals 16. So I get it! When you divide powers, you subtract the exponents. Now remember, it only happens when it has the same base. All right, here we go. Law number 4. Power of a power. If you are raising a power to an exponent, you multiply the exponents. So in variable form, this is what it's going to look like. The quantity x to the m to the nth equals x to the m times n. So an example of this is going to be 5 to the 3rd all to the 2nd power, which will equal 5 to the 30 times 2, which is 5 to the 6. You type that in your calculator, 5 to the 6th power, you're going to get 15,625. So when I take a power to a power, I multiply the exponents. All right, here we go. Law number 5. Product law of exponents. If the product, and product means to multiply, of the base is powered by the same exponent, then the result is a multiplication of individual factors of the product, each powered by a given exponent. So this is what it looks like with variables. I have the quantity x times y to the nth power. So my exponent n is going to go to the x, so it's going to be x to the n times y to the n. Both get that exponent. Now example is going to be a times b to the 2nd power, which would equal a to the 2nd times b to the 2nd. So when I take a power of a product, I apply the exponents to all factors of the product. So it's going to every single thing that's going to be multiplied together. All right. Law number 6, quotient law of exponents. If the quotient, which means we're dividing, of a base is powered by the same exponent, then the result is both numerator and denominator, each powered by a given exponent. So in terms of variables, this is what it's going to look like. If I have the quantity x divided by y to the nth power, it's going to equal x to the n divided by y to the nth power. Example of this is going to be the quantity 2/3 to the 4th power. So 2 to the 4th and 3 to the 4th. The 4th power goes to both of these now. And if I put that in my calculator, I'm going to get 16/81. So when I take a power of a quotient, I apply the exponent to all parts of the quotient. So it's going to both my numerator and my denominator. All right, moving on to law number 7, ladies and gentlemen. Negative laws of exponents. If the base is powered by a negative exponent, then the base becomes the reciprocal with a positive exponent. So in terms of variables, this is what it's going to look like. I have x to the negative m power. So since I have a negative exponent, I have to use the reciprocal of x to the negative m, which is going to be 1 to the x to the m, and then it's becoming a positive exponent. Right, an example of this, I have 2 of them for you. I have 5 to the negative 3, it's going to become 1 over 5 to the 3rd, which can be simplified to 1 over 125. Now, if I have a negative exponent in my denominator, now it needs to be moved to my numerator. So the reciprocal of 1 over 3 to the negative 2 is going to be 3 to the 2nd, which equals 9. So when I have a negative exponent, I switch the base to its reciprocal with a positive exponent. Ha ha ha. If the base with a negative exponent is in the denominator, I move it to the numerator and lose the negative sign. Vice versa also, if it's in the numerator, I'm going to move it to the denominator and I'm going to lose the negative sign. Okay, so we're moving it to the top and bottom and we're getting rid of that negative sign here. All right, our last law of exponents is number 8, the zero law of exponents. Any base powered to the zero exponent equals 1. So with variables, it's going to look like this. X to the 0 equals 1. Now I have a few examples for you for this one. If I have 5 to the 0, it's going to equal 1. If I have a to the 0, it's going to equal 1. And if I have the quantity, so in parentheses, 5 times a to the 0, all of this will equal 1. Anytime I have anything set equal to 0 as an exponent, it's going to equal 1. So 0 factors of a base equals 1. That makes sense since every power has a coefficient of 1. All right, now ladies and gentlemen, I have 2 examples for you. Here's example number 1. We're going to be putting some of these laws of exponents together here. So I have 2 to the x to the negative 3, y to the 4th, all to the negative 3. So first thing I'm going to do is put my exponent to everything that's being multiplied on the inside. So this is going to be 2 to the negative 3 times x to the negative 2. Now if it's a power to a power, I multiply. So times the negative 3 and y to the 4th times the negative 3. Now I'm going to simplify my exponents here. This is going to equal 2 to the negative 3 times x, negative 2 and negative 3 is going to give me to the 6th, and y to the negative 12th. Now I can't have negative exponents, so these are in my numerator. These 2 have negative exponents. They need to be moved to my denominator. So what this is going to equal is x to the 6 is going to stay on the top. On the bottom, I'm going to get 2 to the 3rd and y to the 12th. And I can simplify this one step further because I know what 2 to the 3rd is. So it's going to be x to the 6 all over 8 y to the 12th. And that is my simplified version. All right, ladies and gentlemen, we have one more example and then we're done for the day. So I have these two multiplied times each other at 5x squared, y to the negative 8, times the quantity 2x cubed, y to the 5th. So my numbers are just being multiplied, so I have 5 times 2. Now I have x squared and x cubed. So I have two numbers that are being multiplied with the same base. So that means I'm going to add my exponents. So it's going to be x squared plus 3. And then I have y to the negative 8 and y to the 5th. Same base, so I can add my exponents. So it's going to be y to the negative 8 plus to the 5th. Simplify this. 5 times 2 is 10. This is going to be x to the 5th. Y to the negative 3. Now I can't have negative exponents, so it's in my numerator. I need to move it to my denominator. So this is going to equal 10x to the 5th all over y cubed. All right, that is all I have for you today, ladies and gentlemen. I hope you go out and have a brilliant day, and I will be seeing you later. Bye!